Hello friends, this is Vimal. Welcome to my Mr. Physics channel. Today we will be discussing about velocity time graph. So, figure shows the velocity time graph of a particle moving in a straight line. First, we have to find out the nature of motion of the particle. Second, the displacement of the particle at time is equal to 6 seconds. Third, does the particle change its direction of motion when it is moving? Fourth, compare the distance traveled by the particle from 0 to 4 seconds and from 4 to 6 seconds. And finally, fifth, find the acceleration from 0 to 4 seconds and retardation from 4 to 6 seconds. So, this is the graph which is being given. You can see that from the graph, from the origin O or 0, it is a linear curve and reaches the maximum at 4 seconds, and from there at 6 seconds it is once again descends. So this is the graph given, and we are going to calibrate all the 5 factors which is asked in the question. Now let's go one by one. Now the first one, state the nature of the motion of the particle. This is the graph which has been given. From the graph we can see that clearly the nature of motion of the particle are uniformly accelerated from 0 to 4 seconds. You can see that from 0 to 4 it is a linear curve, that is a straight line curve. So it is being linearly accelerated. That's what is given in the first part. Now the second part is it is uniformly retarded from 4 to 6 seconds. See here, from 4 to 6 there is a descending in the curve. So we can tell that it is uniformly retarded. So now we have clearly given what does the nature of the particular graph shows. So first part, it is uniformly accelerated from 0 to 4, and the second part from 4 to 6 it is uniformly retarded. Now we are going to see the second part. Find the displacement of the particle at t equal to 6 seconds. So when you are checking the graph t equal to 6 seconds, it is from 0 is the starting point and 6 is the ending point. So we can calibrate it into two triangles and we can solve it. So here from 0 to 6 seconds, if you want to calculate it, the calibration can be done very simple, especially in the velocity time graph. If you determine or find the area lying beneath the curve, we can find the displacement. And if you find the slope, we will get the acceleration. So from this, the first part is displacement of the particle. So we are going to see one by one. So the displacement can be determined by finding the area enclosed by the graph in that part with the time axis, which is up to that instance. So by using this particular condition, we are going to check out what is actually happening. So area under the curve, it is a triangle which is being mentioned. So you will get it as displacement equal to area of the triangle. So you are getting two triangles here. So first one 0 to 4, it is on a triangle, and 4 to 6 is another triangle. So here by using the formula half into base into height, we can determine it clearly. So here half into, it is 6 minus 0. From the starting itself we can tell, because at the 6th second they are asking. So we need not worry about what is the actual path taken. So 0 to 6, it is 6 minus 0, and here you can see the maximum displacement at 2. So it is 2 meters. So 0 to 2, that is so higher, that is 2 minus 0. So when you do it, it is half into 6 minus 0 into 2 minus 0. So when you cancel it, you get it as 6 meters. So that is the total path which is being discovered. So if we want to recheck it, that's the second part. The third part, we are going to do it once again. Now the third part, does the particle change its direction of motion? Does it change? We are going to see that. Because the graph doesn't change the motion. Why? It is so simple, because there is no change in the axis. See here, the curve constantly reaches to maximum 4 and comes to 6. So you can see that there is no change in direction. It moves only in one direction. That is what is explained here. Fourth one, the distance traveled by the particle from 0 to 6 seconds, 0, that is 0 to 4, and from 4 to 6. So this is the part we are going to do next. So at t equal to 0 to 4. So how to calculate the distance? It is nothing but the area enclosed by the triangle. So we have to see what is the exact area between 0 to 4 and this particular part. We have to check it. This triangle, we need to check it. So formula is half into base into height. So here either you can take this as the base, or this as the height, or this as the base and this as the height. So usually we will take this one. Any one you can take it. There is not going to be any change. So from this, it is clear that half into it is 4 minus 0. See here, it is T2. The formula is, okay, T2 minus T1. Here it is V2 minus V1. So it is half into, so the maximum is 4 minus 0 into 2 minus 0. When I'm substituting it, you will get the answer as 4 meters. So that will be the condition when the particle is moving from 0 to 4 seconds. Now the second part is at t equal to 4 to 6 seconds. What is the other part? So here once again the same formula, half into base into height. So it is 6 minus 4 and 2 minus 0. See here, it is 6 minus 4 and 2 minus 0. You got it as 2 meters. So when I do the calculation, it has 2 meters. So that's what we have discussed in the first part. So when I'm calculating the t equal to 6 seconds, we got the same thing. So 0 to 4 is 4 meters and 4 to 6 is 2 meters. So the net displacement covered, or the distance covered, is nothing but equal to nothing but 6 meters. Therefore, from 0 to 4 seconds, it is 4, and from 4 to 6 seconds, it is 2. Therefore, the ratio of 0 to 4 is to 0 to 4 to 6 is 4 is to 2. So this is what they are asking, because they are asking to compare the distance traveled. When you are checking the total distance, you just add these to 4 plus 2. That's what we got in the second case, we think. But when we are asking to find out the distance traveled, we are asking to compare us. So when you are comparing it, it is 4 is to 2. It is 2 is to 1. Now the final part, find the acceleration from 0 to 4 seconds. So from 0 to 4, what is the acceleration they are asking? So here you can see that 0 reaches the maximum at 2. I already told you that it is a linear curve and it is 4 here. So how to calculate the acceleration? By the formula. For displacement, we use the area under the curve. For acceleration, we'll be using the simple slope of the curve. Okay, now we'll be discussing it. See here, so acceleration in the part 0 to 4 second is nothing but equal to the slope of the curve in that particular area. So slope is equal to del y by del x, that is change in y-axis by change in x-axis. So here the change in y-axis is 2 minus 0. You can see here 2 is the maximum, 2 minus 0. That's what I wrote in del y. And here it is 4 minus 0. That is the formula is v2 minus v1 by t2 minus t1. So I got it as 2 minus 0 by 4 minus 0. So at the, we are checking with the unit, it is meter per second. Velocity as the unit as meter per second, whereas time as the unit as second. So meter per second by second, you will see that they are getting cancelled, and you get the meter. So it will be 0.5 meter per second square. The first part. Now we are going to find out the retardation. From 4 to 6 seconds, we are going to calibrate the retardation. Retardation is the negative part of the curve. That is from this part, that is from 4 to 6. That is what they are asking us. So here, when to calculate it, retardation once again in the part 4 to 6 seconds is nothing but slope of the graph in that particular area. So acceleration we call it as positive, whereas retardation we call it as negative. So we have to calculate the retardation between 4 to 6 seconds. So slope is given by the formula del y by del x. So you'll get it as from here you can check it over. It is 0 to 2, that is in the y-axis. You can check it over. It is 0 to 2. So 0 minus 2 by, it is timing 6 minus 4. You can check it over here. 6 minus 4. So 0 minus 2 by 6 minus 4. When I do the calculation, you get it as, getting cancelled, you get as minus 1 seconds. It is retardation, so the answer will be in negative. So you should be very careful whenever you are writing the problem, when especially with retardation, the answer must end in negative. So these are the 5 points which we have discussed. Hope you understood. We will meet in the next video. Thank you.